Online pretty clearly and on either. Online students, can you hear me clearly? Online students, can you hear me clearly? Okay, let's start with a set of questions. I'll give you a series of questions. You first start with these questions, then let's move to some additional theory parts, small theory parts. Let's move to those theory parts too after finishing some questions. Okay. So, so I need you to start from where we stopped last week, which means exercise 7, which means exercise start from exercise 7 question 1 and go to exercise 7 question 1, 2. Actually, I need you to do 3, 4, 5, 3, 4, 5, 8, 10. Let's start with these questions. Let's start with these questions. Okay, okay, we'll check on that. Start with these questions. Exercise 7, question 1, 2, 3, 4, 5, 8, and 10. Start with these questions. Tutor will be available in the Zoom chat and the WhatsApp groups too. It's the same tutor as last week, okay? Yeah. Any physical students need tutors? Anyone? All right. We have to start with these questions. Exercise 7, question 1, 2, 3, 4, 5, 8, and 10. Okay. So, to revise the content you need for this, okay? I mean, I asked you to start with these questions because we stopped here, right? Last week, we stopped here. So, like, the content required for this is power. Content required for this is power. Power means work over time, right? Power means work over time. Okay. Power means work over time or energy over time. Energy over time. You can like write it as work over time or energy over time. Then if we continue from this point, okay, if we continue from this point, usually mainly for vehicles kind of stuff, if something moves with a force F, with a constant force of F, and under a constant velocity V, if there's a constant force F and constant velocity V, we were able to change this power equation. We were able to change this power equation like this, right? Uh, Power equals work over time. Power equals work over time. Work equals Fx over time. Fx over time. Work equals Fx over time equals F x over time equals F x over time. X over time means displacement over time, right? X over time means displacement over time. Displacement over time means velocity, right? Displacement over time means velocity. Clear? Displacement over time means velocity. So for in some scenarios, you can use P equals Fv. Okay. For some scenarios, you can use P equals Fv. Clear? So there are different kind of equations that you can use. One is power equals work over time or energy over time, or you can use P equals Fv, but for this you have to fulfill some conditions, okay? The setup should fulfill some conditions, okay? So I need you to keep doing these questions, exercise 7, question 1, 2, 3, 4, 5, 8, and 10. All these questions are related to this concept, okay? All these concepts are related to this concept, okay? I'll start with the first one. I'll start with the first one. Exercise 7, question 1. Exercise 7, question 1. Uh, a crane lifts 30 bags of cement at a time vertically 40 meters at a constant speed. If the time taken for this is 5 minutes, find the working power of the crane. Bag of cement has 50 kilograms. There's a, there are bags. Mass is 50 kilograms. Mass of a bag is 50 kilograms. We lift it up. We lift it up 40 meters vertically up. We lift it 40 meters vertically up. And if I like roughly explain about the session, last week we did the work power energy theory session. Took like 6 hours for that. Last week we did work power energy theory session. Today is mainly covering the questions and remaining small theory parts uh, just for the completion. Okay. So last week we finished almost all the theory points. Today we have like very few theory points left to do and some additional questions. Okay, that is the plan for today. Okay, then today we can finish everything related to work power energy. That's why I decided to do a session this week also. So we lift these 50 kilogram bags. We lift these 50 kilogram bags 40 meters up, 40 meters up, and it takes 5 minutes to lift 30 bags. To lift 30 bags, it takes 5 minutes. Okay, so the idea is this. Okay, power equals work over time. Work over time. In this case, work converts into mgh, right? Potential energy. Whatever the work we do, it converts into potential energy, mgh, right? Here we lift bags. Okay, here we lift bags. That means whatever the work we do eventually turns into potential energy, right? Okay, whatever the work we do eventually turns into potential energy. Clear? It turns into potential energy. So work becomes mgh. Work becomes mgh over the time taken for it. So what is the mass of a bag? 50 kilograms. Mass of a bag is 50 kilograms. G means 10. G means 10. Height h is 40 meters. Height h is 40 meters. We lift it up by 40 meters. Height is 40 meters. This is the potential energy difference of one bag, and we lift 30 bags like that. We lift 30 bags like that. mgh into 30. mgh into 30. We lift 30 bags like this. And the time taken for this process is 5 minutes, which means 5 into 60. 5 into 60. You solve this, you get the answer. Clear? You solve this, you get the answer. Clear? Okay. If anyone need the tute, you can find it in the Zoom chat. Okay. Put the tutes in the WhatsApp groups. And you will be able to find it in the WhatsApp group too. You'll be able to find it in the WhatsApp group too. Let's keep doing these questions, and I'll give some additional questions on the board too. Question 2. Question 2. When an object is placed on a rough surface and it moves with a uniform velocity 10, the force to be applied on the object is 20 newtons. What is the power here? So, there's an object like this. There's an object like this. If you need me to explain the theory parts again, let me know. I'm just continuing from where we stopped last week, okay? That's why I'm like directly going with the questions. But if you can't remember the theory, if you didn't join the theory sessions, if you need me to explain the theory parts again, just let me know. When an object is placed on a rough surface and it moves with a uniform velocity of 10 meters per second. This moves with a uniform velocity of 10 meters per second. And the force to be applied on this is 20 newtons. Force to be applied is 20 newtons. What is the power here? Power equals Fv. P equals Fv. What is the force? 20 newtons. Force is 20 newtons. Force 20 newtons. Velocity 10 meters per second. Velocity 10 meters per second. Force 20 newtons. Velocity 10 meters per second. P equals Fv gives us 200. Unit of power is what? Unit of power is what? Which means joules per second. Which means joules per second. What? Or joules per second. Clear? Sometimes you can directly use this equation P equals Fv. Question 3. Question 3. An object of mass 50 kg is placed on a horizontal surface with a coefficient of friction 0.4. Find the power required to move it with a uniform velocity of 2 meters per second. This is the idea. There's an object, mass 50 kilograms. 50 kilograms means 500 newtons. Mass 50 kilograms means weight 500 newtons. If the weight is 500 newtons, normal reaction is also 500 newtons. Normal reaction is also 500 newtons. If the weight is 500 newtons, normal reaction is also 500 newtons. Then the friction will be, dynamic friction will be, F dynamic will be mu r. Mu r. Mu is given as, in the question, mu is given as 0.4. Mu is given as 0.4. And the normal reaction is 500. Normal reaction is 500. 0.4 into 500. Fd, that means the friction, dynamic friction, mu r, mu means 0.4, r is 500. This means 4 into 50, right? This means 4 into 50, which gives you a dynamic friction of 200 newtons. Gives you a dynamic friction of 200 newtons. So to move this under constant velocity, of 2 meters per second, to move this under constant velocity of 2 meters per second, we should provide a force of 200 newtons. We should provide a force of 200 newtons. To move this under constant velocity of 2 meters per second, we should provide 200 newtons in forward direction, right? Why? There's a friction of 200. There's a friction of 200. So to move this against this friction under constant velocity, we should provide 200 too, right? Okay? We should provide 200. There's a dynamic friction 200, so we should provide 200. So now, again, P equals Fv. P equals Fv. I can find the power using Fv. And the force I should provide is 200 newtons. Force I should provide is 200 newtons. Force is 200 newtons. And under this force, this should move with a velocity of 2 meters per second. This should move with a velocity of 2 meters per second. Clear? Against the friction, we should provide 200 newtons. We should provide 200 newtons. And under that 200 newtons, this should move at a constant velocity of 2 meters per second, which will give me 400 watt. Which will give me 400 watt. Clear? Okay. P equals Fe. P equals Fe. quickly do write if you had to write anything. And online students, please let us know if there's any issue. Okay, early morning we had issue with SLT. Now I think things are resolved, but we are running on hotspot. We'll see. Okay, there are issues with the temperature. Let us know if it is still cold. Thank you. Question 4. Question 4. An object of mass 5 kilograms, raised by 10 meters, and thrown with a velocity of 4 meters per second. If the time taken by the machine is 10 seconds, find the total work done by the machine. Okay. So it's quite easy. They are asking find the total work done by the machine. I actually need you to find the power, okay? I actually need you to find the power here. What is the idea? So object of mass 5 kilogram raised 10 meters up, then thrown with a velocity 4. If the time taken by the machine is 10 seconds, find the total work done by the machine. So here again, I need you to find the power, okay? Power means work over time. So in this case, work is mgh plus half mv squared, right? You are lifting it up. That means you are giving it a potential energy. Then you throw it, right? Clear? Work means in this case mgh, because you lift it up, which provides it a potential energy. Then you throw it with half mv squared, right? So it is potential energy plus kinetic energy. Clear? It is potential energy plus kinetic energy. Okay? You provide both within a given time. So you just apply values to this. What is the mass? 5 kilograms. G 10. Height 10 meters plus half. Mass is again 5 kilograms. Velocity 4 meters per second. Divided by time. Which is time taken for the full process is 10 seconds. This is your power. Clear? You just get the energy difference, then you divide by time, okay? You just get the energy difference, then you divide by time. That is the idea. I think there's no issue now. Let's go to question 5. 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 A well 20-meter deep, a well 20-meter deep, a well 20-meter deep, 20-meter deep, has water to a height of 6 meters, has water to a height of 6 meters. Cross-sectional area of the well is 4 meters, 4 meters squared. Cross-sectional area of the well is 4 meter squared. 4 meter squared. Density of water is 1000. Density of water is 1000. Density of water is 1000. The work to be done to lift that water up. So this is the idea, okay? For this you may need a bit, not a better, but at least a rough understanding about center of gravity, okay? You may need a rough understanding about center of gravity. There's no other way. Why? The problem is, otherwise you have to do the question considering particle by particle. Otherwise you have to do the question considering particle by particle. Why? Now, you need to lift this water to this level, right? You need to lift this water to this level, right? Okay. All this water, you need to lift it up to this level. Okay. What is the problem here? What is the problem here? If you consider this particle should be lifted only 14 meters. If you consider this water particle should be lifted by 20 meters. If you lift this water particle, it should be lifted by another height. This particle, another height. So, different particles at different heights, okay? Different particles at different heights, okay? Different particles at different heights, you have to lift by different amounts, clear? You have to lift by different amounts, clear? Different particles, you have to lift by different heights, okay? So you can't actually do that, right? How many particles and how many heights, okay? In such issues, what we do is we have a slight understanding about this from last week's session, but this Thursday only we have to start center of gravity, right? We have to start center of gravity this Thursday, okay? But rough understanding we have now about center of gravity. Center of gravity means the point that we consider as the representative of the whole weight. I mean, I use the same example, okay? If this pencil is made out of millions of particles, but if I keep my hands like this and bring my hands together, pay attention, if I place my hands like that and bring my hands together, it stops at a certain point. It stops at a certain point. If I place my hands like this and if I bring them together, it stops at a certain point. Okay? It stops at a certain point. This point, when I place my hand here, the pencil is balanced, right? Although the pencil is made out of millions of particles and they have their own weights, by placing my finger here, I can balance that. Why? Because the overall weight, that means resultant of the whole weight, overall weight is acting from this point. That means the sum of the weights of all the particles, sum of the weights of all the particles acts through one single point, acts through one single point, that is center of gravity. That means that is the representative of all the weights. Clear? The whole weight acts through that point. Clear? So in this case, in a uniform system like this, center of gravity lies exactly at the middle. If this pencil was uniform, it will be at the exact center, okay? And throughout the class, I need you to do something, okay? This is something additional, not related to this question. I need you to explain this. Reason for this, I need you to write this, explain this using equations, or write this using a paragraph. What is that? Just an additional work. Whatever I do, when I place my fingers like this, okay, in any object, when I place my fingers like this, and if I bring them closer, okay, without any pattern, anyways, I stop at the center of gravity, see? Anyways, my fingers stop at the center of gravity, okay? No matter how fast I move, I'm not doing this in any organized manner, okay? I just bring my hands closer to each other, okay? But I always end at the center of gravity. I need you to explain it, okay? I need you to explain it using a paragraph or using equations, okay? These kind of stuff are really important because like at the end of the day, you know a lot of physics, but sometimes like converting it to an answer, you know physics, you have a quite understanding about this, but like converting it into a paragraph or explaining it using equations, you find hard sometimes. But that's the most important skill for A levels, right? Because at the end of the day, at A levels, you have to anyways do that, right? You have to anyways explain stuff. You have to anyways explain stuff using words, okay? Not your intuition. You having a slight idea about this is not enough, right? You having a slight idea about this is not enough. You must be able to write it in precise words, right? You must be able to write it in precise words, okay? So anyways, it's an additional thing, okay? I need the perfect paragraph as the answer. Don't give me a just bunch of slide like roughly explained statements, or just don't tell me, okay, isn't this happening, like a very rough idea, not like that. What I need you to do is, if you have time throughout the class, I need you to explain this as a perfect paragraph, or as a perfect set of equations, okay? As a perfect set of equations, okay? Okay. So what happens is, this is the center of gravity of water, right? Now, it represents all the water particles, right? It represents all the water particles, and about center of gravity, you will get a better understanding, like about center of gravity, you will get a better understanding next week in the class, because we are starting center of gravity. And the center of gravity, now you bring all the water here and you spread water like this, right? You bring all the water here and you spread water like this, right? This is not a solid. You don't get this water like this and keep it like this, okay? This is not a solid, okay? This is not a solid. You don't bring this water and place it like this, right? You just, when it comes to the surface, it just spreads on the surface, right? That means its center of gravity goes from this level to this level, right? Its center of gravity goes from this level to this level, clear? Center of gravity goes from this level to this level, clear? Then, what is the height of the center of gravity here? How far does the center of gravity goes? If this is 6, if this is exactly the center, if this is exactly the center, then this is 3. Then this is 3. This is 6. This is exactly the center. Then this is 3. So what is this height then? 20 minus 3. 20 minus 3, which means 17. 20 minus 3, which means 17. So you bring this water up by 17 meters, right? You bring this water up by 17 meters. Now you don't have to worry about each particle because you are considering the representative of all the particles, which is the center of gravity, right? Clear? Clear? So you have to lift this whole bunch of water by 17 meters. So the question is work done to lift that water up. So the thing is work equals here mgh. Why? The work you do to lift this up converts into potential energy, right? Work you do to lift this up converts into potential energy, mgh. Clear? Work you do converts into potential energy, mgh. Okay. Then what is the mass? What is the mass? That you have to find separately. Why? First get the volume of water. First get the volume of water. Volume of water is here area 4. Here area 4. Height 6. Clear? Volume of water is area 4. Height 6. Right? This is the volume of water. Then what is the mass of water? Volume into density. Right? You multiply volume by density to get the mass. Right? You multiply volume by density to get the mass, which means volume is 24. Volume is 24. Density of water is usually 1000. Density of water is usually 1000. Clear? Then the mass is this. This is the mass. Volume into density, 24 into 10 to the power 3. 24 into 10 to the power 3. Then you have G, that means 10. Then you have G, that means 10. Then you have the height. What is the height? You lift it by 17 meters. You lift it by 17 meters. This is the work you do to lift this up. Okay. Then work done to pump the water with a velocity of 10. Now, work done to pump the water with a velocity of 10. I'll take this as W1. To pump the water, you should provide a kinetic energy to water, right? To pump the water, you should provide a kinetic energy to water, right? Okay. So to pump all this water with a certain velocity, what you should write is half, and what is the mass of water? Again this value. This is the mass of all the water, 24 into 10 to the power 3. Mass of all the water is 24 into 10 to the power 3, half m. V squared, what is the velocity? V squared, what is the velocity of water? 10 meters per second. 10 meters per second. That is the work you should do to pump the water. Clear? That means you are actually throwing water with a velocity of 10. Clear? You are actually throwing water with a velocity of 10. That means half mv squared. Clear? The work you do to pump water turns into kinetic energy. Half mass is 24 into 10 to the power 3 v squared, velocity squared. If the time to completely remove the water is 30 minutes, the power of this machine. What is the power of this machine? Power of this machine can be taken as work over time. Work over time. Now the idea is overall work here means W1 plus W2, right? Overall work here is W1 plus W2 over time, right? Clear? Why? You first lift the water up, then you throw it, right? You first lift the water up, then you throw it. Clear? So W1 and W2 both are a part of the work of the motor, right? You lift it, W1, then you throw it, W2. Clear? So you get, like, if you try to solve these, 24 into 10 into 17, 24 into 10 into 17 into, here you get 4080 into 10 to the power 3. Here you get 24 into 10 to the power 2 divided by 2, 1200, 1200 into 10 to the power 3. So you add these two, this one and this one. 1200 plus 4080. 5280. When you add W and W2, 5280 into 10 to the power 3. 5280 into 10 to the power 3. And it takes 30 minutes for this process. It takes 30 minutes to do all this work. So 30 minutes means 30 into 60. 30 minutes means 30 into 60. Clear? 30 minutes means 30 into 60. This is the power. Total work done divided by time. Total work done divided by time. 5280 into 10 to the power 3 divided by 30 into 60. You get 2933.33 watt. Definitely bring the logbook and try to get final answers always. You will not get a separate time to learn this stuff. So just try to do them when you are doing exercises in the class, okay? You won't get a separate time for that. 2933.33 watt. 2933.33 watt. This is the power. This is the power. If the efficiency of the machine is 75%, what is the total power supplied to the machine? Last week I did efficiency too, right? Definition of efficiency. Yes, right? Yep. So this is the power of the motor. That means the actual work done. This is the power of the motor. That means the actual work done by the motor, okay? This is the power of the motor. That means the actual work done by the motor, okay? But usually any machine takes more power than the work it do, right? Any machine takes more power than the work it do. Why? If you take a pump, definitely, usually a pump release a sound, right? Assume this, let's forget everything else. Usually a pump release a sound, right? Sound is a type of energy. That means from the electrical energy it receives, okay, other than moving water, it converts a certain amount into sound energy. And when a pump works, its temperature goes up. When a pump works, its temperature goes up. It's a machine. Any machine heats up when it works. That means from the electrical energy it receives, it converts a certain part into heat energy. Like that, there are a series of energy conversions, right? That means any machine is not 100% efficient. It converts some of the energy it gains into other types of energy other than moving water. Okay. So they have given that the efficiency is 75%. They have given that the efficiency is 75%. And efficiency is power output. That means the actual work done by the machine. Power input, electrical energy supplied to the machine into 100%. So I can write what is power output. It is the actual wattage of the machine. Actual work done by the machine, 2933.33. 2933.33. Then P in, power in. That's what they need us to find. Power supplied to the machine into 100%. So use all this. You bring P in here, 75 here, percentage and percentage cancels out. So you get P in equals 2933.33 into 100 divided by, you bring 75 here, P in up, divided by 75. Clear? 2933.33 into 100 over 75. You provide 3911.1 watt. You should provide a power of 3911.1 watt into the machine. 3911.1 watt into the machine. Yes, tubes will be delivered, okay? Tubes will be delivered soon. If you still didn't get the tubes, if you sent a message earlier, then it will be delivered within these weeks, okay? Don't have to worry about that. If you are new, just contact this number, send a message to this number requesting for the tube, not 70-154-6825, not 70-154-6825. Let's try question 12. Let's try question 12 a bit. It's also related to water. Let's try question 12 a bit. Go to question 12. Write this down and go to question 12. This is question 5. I'm like focusing more on this area because we were able to do questions from other parts last week, right? We were able to do questions from other parts last week, but we weren't able to do any questions from power. That's why I'm focusing on these questions a lot. Question 12. Question 12. I have asked you to do question 12. Anyone still writing this? Anyone? Pay attention, everyone. Try to finish the questions in the given time. Today is like, now I think the essay paper is running, A-level essay paper. We'll see how the paper looks like. But I don't think that the essay would go this year from physics. Would go through from maths or bio. I think the essay score will be decided. Last year it was mainly chemistry, as I remember. This year it looks like maths or bio, like maths and bio. So next week probably it would be physics again. Next year it will be most probably physics. It's not for you guys, you are 27 batch. So yeah, the year after that we don't know what would happen. Everything like will be based on the decisions of our prime minister, I think now. Because the panels may change sometimes. Okay. If the panel changes, papers become difficult usually. That's what happens to the chemistry paper last week. Dharanegala sir made the paper for like years, like around 18, 20 years. It's also quite important, pay attention, uh, like chemistry, for chemistry, there's a very easy method of like getting a smooth result for chemistry. It is doing the past papers again and again and again, maybe 10 times, if possible 15 times. Do the past papers again and again, 1,000 times maybe, because it worked for like 15, 20 years, it worked, okay? For 15, 20 years, that method worked because same scenario for physics, definitely you'd have to do past papers at least one times properly, or maybe one, two, three times. It's good if you can do the past papers, because anyways the papers, the best model paper for A levels is past papers, right? Okay, so definitely you have to do that. But for chemistry, it was very convenient because the same person made the paper for like 18, 20 years, okay? Dharnekala sir made the paper for years, okay? But last year chemistry papers were difficult for the people because people were so accustomed to this method. But the problem was the person who made the paper changed, okay? The Dharnekala sir will not be making the paper again, okay? So I met him like 2, 3 days before. So he will not make the paper again. So now the chemistry paper may vary time to time. It won't have the flavor of past papers. That has been the problem. That's why last year results dropped. Many students struggled for chemistry last year due to this issue. Because the person who made the paper for 18 years, 18 to 20 years, now he is not making the paper anymore. Now all the past papers and the new paper is different. All the past paper and the new paper is different. The flavor of the paper is different. No matter what you do, you can't prepare a paper that is similar to other papers because it's made by another person. Okay, so everything changed. So that's why the chemistry paper was a bit hard. Not because the chemistry was hard, the flavor of the paper was different, and people were not used to that. Same thing happens like 2019 physics paper. The person who made the paper changed. Okay, 2019 physics paper was extremely difficult because the person who made the paper changed. So the flavor changes. Our people don't learn the subject. Our people learn and keep studying the papers again and again. Our people don't like to put the subject into the heads. You just learn a bunch of methods and go to the paper. And all these methods are made using the past papers. If the person who make the paper changes, then you are in trouble. Okay, that is the only thing. So you have to do two things. Yes, do past papers as much as possible. We'll do that anyways. Okay, I usually after finishing the syllabus, I usually finish syllabus 6 months before. After that, we do past papers again and again. Yes, definitely do that. Maybe one time, maybe 2-3 times. Yes, but other than that, you have to do new questions too. In case of the panel changes, okay, if the panel changes, the flavor of the paper changes entirely. So you won't see a paper similar to past papers in that case. Okay, we have to be ready for both scenarios. You have to be ready for both scenarios. Okay, so just follow both methods. Okay, don't rely on any method. Okay. Question 12. Question 12. So what I need you to do is, yes, follow the traditional methods, do the past papers, maybe 1,000 times, I don't care. Okay, okay, do the past papers, follow the traditional method, but be ready for new stuff too. Okay, you have to do both. Okay, because some teachers advise you do model papers, some teachers advise you no, do past papers, don't touch model papers, just do past papers, don't touch model papers, do past papers. Some teachers advise no, do model papers. We are doing the best series of model papers. You have to do that. Okay, just come to the middle ground. Okay, both matters. Okay, both matters. Do past papers. Okay, follow the traditional methods. Okay, do past papers as many times as possible. Okay, but do model papers too. Okay, okay. Both methods don't work alone. Okay, both methods would fail if you just follow one method. Okay. Okay. Question 12. A pump with a tube, cross-sectional area 10 centimeters squared. Cross-sectional area 10 centimeters squared. Pumps water from a well located at a depth of 5 meters. At a well located at a depth of 5 meters. Above the water surface and releases it with a velocity of 1,000. We bring it 5 meters up and release it with a velocity of 1,000. But it is 1,000 centimeter cube per second. It is 1,000 centimeter cube per second. 1,000 centimeter cube per second. If the power of the pump is 100 watt, power of the pump is 100 watt. What is the efficiency of the pump? Density of water 1,000. Density of water 1,000. Okay. The pump with a tube of cross-sectional area 10 centimeters squared. Okay. So this is the idea. Power of the pump. They need us to find the efficiency of the pump. This power means the power input of the pump. Usually there's a power written on the pump. Okay, this is a 100 watt pump. This is a 240, maybe like you provide the voltage and power both. Okay, there's a 100 watt power supply. There are 200 watt power supply, 50 watt power supply, 15 watt power supply, 20 watt chargers, adapters. Okay, every device holds like a certain power value. That is actually the power it consumes. Okay, that is actually the power it consumes. So a 100 watt pump means it consumes a power of 100 watt. Okay, 100 watt pump means it consumes a power of 100 watt. Okay, So you have to find the power output. That means the actual work it does. Okay. So in this case, it emits 1000 centimeter cubes per second. Okay. It emits 1000 centimeter cube per second. So the idea is this. It lifts all this water by 5 meters, right? Okay. In a scenario like this, it's more convenient to, they haven't given us a specific time. Within 5 seconds, within 10 seconds, there's no such information. It's just a continuous information. There's a continuous water flow of 1000 centimeter cubes per second. There's a continuous water flow, okay? There's no any reference to a specific time gap. It's just a continuous water flow of 1000 centimeters per cube per second. That means at every second there's 1000 centimeter cube going out. So it's much convenient to analyze the whole question considering 1 second. It's much convenient to analyze the whole question considering 1 second. That means if I consider what happens in 1 second, it is 1000 centimeter cubes per second. That means volume of water, I'll write it as VO, volume of water that goes out per second is 1000 centimeter cube per second, 1000 centimeter cube per second multiplied by 1 second. You get 1000 centimeter cube. That means 1000 centimeter cube of water, 1000 centimeter cube of water comes out from this pump per second. Then what is the mass of water per second? It is volume into density gives you the mass, right? Volume into density gives you the mass, right? Clear? So volume is 1000 centimeter cube converted into meter cube, you get 10 to the power minus 6, right? Centimeter cube converted into meter cube. You need to convert this centimeter cube into meter cube. 10 to the power minus 2 into 3, right? Which gives you 10 to the power minus 6. This is the volume in meter cube. This is the volume in meter cube. Then what is the density? Density of water is 1000 kilogram per meter cube, right? Standard density of water is 1000 kilogram per meter cube. Clear? Then when you solve this, 10 to the power 3, 10 to the power 3, 10 to the power minus 6, you get 1 kilogram, right? When you solve this, you get 1 kilogram, right? 10 to the power 3, 10 to the power 3, 10 to the power minus 6. Things cancel out and you get 1 kilogram. Clear? You get 1 kilogram. Okay? That means per second, 1 kilograms of water comes out of this. Okay? Now, tell me, what happens to this 1 kilogram within second? We lift this 1 kilogram of water by 5 meters. We lift this 1 kilogram of water by 5 meters. Then we throw this water with a certain velocity. Then we throw this water with a certain velocity. We lift 5 kilograms of water. We lift this 1 kilogram of water by 5 meters. Then we throw this water with a certain velocity. Clear? What is the velocity of the water? Pay attention. What is the velocity of the water? What is the velocity of the water? It is I can write like this. Pay attention. I can get the velocity like this. It is 1000 centimeter. It is 1000 centimeter cube of water per second. Okay? You divide it by the area. You divide it by the area, which is 10 centimeter squared. You get, when you solve this, 100 centimeters per second. Got the idea? The volume flow rate you divide by area, you get the velocity, right? Got the idea? The water goes out here with a certain velocity. Water goes out here with a certain velocity. You get that velocity and you multiply it by the area of the pump, you get how fast the volume goes out, right? Because velocity means length per second. That means velocity is length. Velocity means the length of water per second. The length of water that goes out per second, right? Velocity of water means length of water that goes out per second. Clear? You multiply this length by the cross-sectional area of the pump. You get the volume of water that goes out per second. Clear? You get volume of water that goes out per second. Clear? That means velocity of water multiplied by area. So length means velocity into 1 second, right? Length means velocity into 1 second, right? Length of water per second means velocity into 1, right? You multiply velocity of water by area of the pump of the tube, you get the volume per second. Got the idea? Clear? Because if I explain it better, velocity into area means length divided by time into area, right? Velocity means length divided by time into area. Length into area over time, what do you get by length of area? Length into area means volume, right? Length into area means volume, right? You get volume over time. Clear? So velocity of water into area gives you volume per second. Gives you volume per second. Clear? So to get the velocity of water, what you do is, you get volume per second. What is volume over time? It is 1000 centimeter cube per second. Then you divide it by area. Clear? Even by units you can see, right? Centimeter cube per second divided by centimeter squared, you get centimeter per second, unit of velocity, right? So if you convert it into meters per second, 100 centimeters means 1 meter, right? Yes, right? 100 centimeter means 1 meter. So the velocity is 1 meter per second. 1 meter per second. Clear? So now we have all the information required. We know what happens in 1 second now. What happens in 1 second? You get 1 kilograms of water. In 1 second, you get 1 kilogram of water. Okay. Then you lift it by 5 meters. Clear? Then you lift it by 5 meters. You lift it by 5 meters. Clear? This 1 kilogram of water, you lift it by 5 meters. Then this 1 kilogram of water, you throw it with a velocity of 1 meters per second. With a velocity of 1 meters per second. See, when I clarify everything into 1 second, it's much convenient and easy to understand, right? Clear? So in 1 second, this every information is related to 1 second, right? Clear? In 1 second, you bring 1 kilogram of water, lift it by 5 meters, you throw it with a velocity of 1 meters per second. Clear? So what is the power output? Power output is work done over time, right? Work done over time. Now, this full process is for 1 second, right? This full process that I figured out here is for 1 second, right? That means the time is 1 second. Time is 1 second. Clear? Time is 1 second. What is the total work? You lift it up, mgh, then you throw it half mv squared, which means mass 1 kilogram, g means 10, you lift it by 5 meters, mgh. Mass 1 kilogram, g means 10, you lift it by 5 meters, mgh, plus half, 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 what is the mass? Again 1 kilogram, then v squared, what is the velocity? 1 meters per second squared. 1 meters per second squared. Clear? 1 meters per second squared divided by 1. This is your power output. This is the power output. Clear? So what do we get here? 10 into 5. We get 50.5, right? We get 50.5. We get 50.5 watt. So the idea is they need us to find the efficiency. Efficiency means power out over power in into 100%. This is efficiency. Power out over power in into 100%. That is efficiency. Which means 50.5 watt. What is power in? Power in is 100 watt, right? This is a 100 watt motor. This is a 100 watt motor. That means power in is 100 watt into 100%. Into 100%. Clear? 50.5 over 100 into 100%. You get the efficiency as 100 and 100 cancels out. 50.5%. 50.5%. Clear? Do you know Newton's law of restitution? Yes? Yes? No? No? Newton's law of restitution? No. Newtonගේ ප්‍රත්‍යාගති නියමය? No. Let's do that too. Something out from our syllabus, but will be convenient. And again, one of the main reasons I did work power energy is for you to, even though you're not getting it for the term test, first term test, like it will be really convenient for many MCQs, okay? You have seen that, right? When we were discussing questions, now it makes a lot of questions very easy, okay? Okay? Now it makes a lot of questions very easy. Instead of using motion equations, using work power energy is quite easy, okay? We'll see. Every week when we are doing MCQs in the class, you will see that, okay? So even though you are not getting it for your term test, okay? Use work power energy equations for MCQs, okay? Because it's 25 MCQs in 1 hour in your first term test. It's a lot of work, okay? It's a lot of work. So you need all the short methods possible for that. And they will not know what is the method you used. They will give you a very lengthy question at school, assuming that you don't know work power energy. Some questions takes a lot to do using motion equations, right? Okay, then you can quickly get the answer using work power energy. Write this down. there are some questions. There are some questions. Yeah, pay attention. Pay attention. Like the idea is this. Like one question. It's a good question because I followed the same method before. Why didn't I get half of 5 meters? Anyone still writing this? Still writing this? No? Okay, pay attention. Pay attention. There are some questions related to this. I'll explain them, but while I'm doing that, you can try, if you understood the question very well, you can try exercise 5, question 10, 14 and 15. You can try exercise 5, question 10, 14 and 15 while I'm explaining the other questions asked by the students, mainly online students. Exercise 5, question 10, 14 and 15. Exercise 5, question 10, 14 and 15. So the questions are, pay attention everyone, pay attention. Why didn't I consider half of this height? Don't I consider the center of gravity in this case? Why didn't I consider half of this value? These are like absolutely valid questions, right? Why didn't I consider half of 5 in this case? Why didn't I consider center of gravity? The question is not clear about the center of gravity. Pay attention. Question is not clear about the center of gravity. That means what they mention in the question is a well 20-meter deep has water to a height, so that is 5, 10. A pump with tube of cross-sectional area 10 centimeters squared. Pay attention, stop talking. Pumps water from a well located at a depth of 5 meters above the water surface and release it with a velocity of 10 centimeter cube per second. So it's like this. There's a pump, there's a well, there's a well. Pumps water from a well located at a depth of 5 meters above the water surface. The question is that not that clear, but the idea is water surface is here. Your pump is here, 5 meters above, 5 meters above. You are taking water mainly from the surface in this case. You are taking water mainly from the surface in this case. Okay, pump is 5 meters above the surface of water. This is not a scenario, pay attention properly. This is not a scenario that you have a well, you bring all the water out from the well. This is a scenario which there's a huge pond or again a water surface like this. You take water from that surface and pump. You take water from that surface and pump. They are not talking anything about the depth of the well, area of the well, nothing, no information about that, right? They are not giving any information about the area of the well, depth of the well. So how can I find a center of gravity? Depth of the well is not given, area of the well is not given. They are only telling that pump is 5 meters above the surface of the water. They are only telling that pump is 5 meters above the surface of the water. In a question like this, what we assume is this is a well with more than enough water. Okay, usually in any well, water level does not decrease when you pump it for day-to-day usage, right? In question 5, you pump, they are definitely giving the size of the well, okay? Then you are pumping the well out, okay? You are pumping the water, all the water in the well out. It's a different scenario, okay? You are pumping, because they are giving information like, if the time to completely remove the water is 30 minutes in question 5, that means they are talking about removing all the water from the well and put them out. That's why in question 5 I considered the center of gravity of water, because they are talking about removing all the water from the well. But generally, when you are using a pump, you don't remove all the water from the well, right? You just get some water from the surface and usually it refills, right? It refills, okay? It refills the depth of, for if you pump water for day-to-day usage from a tank or a well or anything, water level doesn't go down, right? There's a supply of water, continuous, okay? You can never remove all the water from a system like that, okay? So in this case, they are just telling, in question 12, they are not talking about removing all the water from the well. They are talking about a well, general usage well, which doesn't decrease its height with time. When you take water for general usage, the water level of tank well don't go down, right? Because there are water supply to a well always. So it's just you are taking water again and again from this 5 meter height from the surface. Because from the given information, they are not talking about removing all the water from the well. They are not talking about the height or depth of the well. They are not talking about the area of the well. They are just telling you the pump is 5 meters above the surface. That means you are just taking water from the surface continuously. But in question 5, I had to consider the center of gravity because they are talking about removing all the water from the well, not taking water from for usage. Okay, not maybe to clean the well. Okay, maybe to clean the well, they are taking all the water out. Then I had to consider center of gravity. But here they are talking about taking water continuously from the surface of the well. That's what usually happens in a well, right? Okay, the level doesn't go down. You just take water continuously from the same level. Ah, that's this question. That's the difference. Okay, the student who asked about the center of gravity, is that clear? Others keep doing the questions. Okay, you don't have to listen if you are okay with the idea. Okay, got the idea? The student who asked the about the center of gravity thing. It's good. Like it's a valid question. Got the idea? Nice. Uh, so again, how did I get that? I get 1 kilograms of water in 1 second. I mean, there are some. I mean, if you understood the question, don't worry about these issues. Okay, the more you worry about these issues, more complex it get. Okay, okay. Otherwise, but for the understanding of the, like, just for the better understanding of the students who ask the questions, I'll mention these stuff. Otherwise, if you understood this, just keep doing the question. Don't worry about this information. Yes. How did I consider that 1 kilograms of water will be lifted up in 1 second and will be removed from this point within 1 second? Yes, I know that's not actually what happens. Some water comes out here, some water goes up here. Okay, definitely. It's not the same water. It's not the same water. Pump is anyways filled with water continuously. Some water comes out, some water moves to the pump. Okay. But at the end of the day, the resultant is, pay attention, stop talking. At the end of the day, the resultant is you take 1 kilogram up and you remove it, right? With this velocity. Definitely it's spread out. You are taking at the moment, you are removing a set of water here, you are taking another set of water here. But the overall effect is somehow when you consider a second, you have lifted some amount of water here, 1 kilograms of water here, and you have removed 1 kilograms of water here, right? You need to remove 1 kilograms of water here to lift water of 1 kilograms, right? So the 1 kilogram you lift will be another kilogram, and the 1 kilogram you remove here is another 1 kilogram that you took previously. But at the end, the overall thing that happens in 1 second is you lift 1 kilogram up and remove 1 kilogram out, right? Clear? That means, yes, I understand. Already, if there is 1 kilograms of water filled here, that 1 kilogram you put out. Okay? Then from the well, you bring another 1 kilogram in. So it's not the same 1 kilogram you are lifting up and removing. But within 1 second, the overall effect that happens is you lift certain 1 kilogram up and you remove certain 1 kilogram out, right? So the overall effect that happens in 1 second is you lift 1 kilogram up and 1 kilogram out. Definitely it will be two sets of mass. Why? If the pump is already filled, it will first remove the filled water, 1 kilogram. Then to fill that, it will bring another 1 kilogram up. But within a second, the overall impact that happens is you raise some 1 kilogram up and you remove some 1 kilogram out with a certain velocity. That means the overall thing that you do is you lift 1 kilogram up and give a certain velocity to that 1 kilogram. Clear? Okay. If you understood the question, don't worry about this. Okay. That's why I took within 1 second, it is 1 kilogram that comes out. Volume rate into density gives you mass rate. This is volume per second. This is density, gives you mass per second. Volume per second into density gives you mass per second, which is 1 kilogram. That means you bring 1 kilogram to a 5 meter height, then you throw it with a velocity of 1 meters per second. Power becomes 50.4 watt. Clear? Power becomes 50.5 watts. Clear? Got the idea? At least send a sheet if you need me to explain things again. Online students who asked questions, is it clarified everything? Just let me know if you have any additional questions or questions that I didn't answer. මාරුවෙන් සීතලයි කියලා සිට්ටෙනවා රස්නයි කියලා සිට්ටෙනවා. I mean, I explained you the subject, right? You just choose the proper area and sit, okay? I mean, the whole is divided into seasons. You have winter, summer, like. So you just choose the proper area and sit. Go to these questions and let me know if everything is okay. Question 7 students have asked, I'll do that. Everything else is about interval. Again about AC. Again interval. No subject related questions? Some students are asking exercise 7, question 7. I'll do that too. Then let's move to this. I hope online students, all the questions are clarified. Let me know. Exercise 7, question 7. As a boat moves, the resisting force acting against the motion is directly proportional to the square of the speed of the boat. It has a power of 400 watt when moving at a speed of 5. What is the power of the boat when it is speed changed to 10 meters per second? So this is the idea. Now there's a boat. Its velocity is v. Pay attention. Its velocity is v. The force against the motion is directly proportional to the square of the speed of the boat. That means this is the resistive force on the boat. This is the resistive force on the boat. The resistive force on the boat is proportional to the velocity squared. Clear? If I put a proportionality constant, it becomes F equals kV squared. If you put the proportionality constant, it becomes F equals kV squared. Okay. Then the resistive force is kV squared. So to move under a constant velocity, the motor of the boat should provide the same force forward, right? Okay. Resistive force is kV squared. To move under constant velocity, the motor of the boat should create an equal force forward, right? Clear? Then the question is related to power of the boat. So at the moment, power of the boat means power of the motor of the boat, right? Okay. The motor of the boat do the work, right? So power of the boat means power of the motor of the boat. So now the power, I can apply P equals Fv, constant force, constant velocity. P equals Fv. So the force is equal to the resistive force, clear? Force is equal to the resistive force, clear? Which is kV squared. Which is kV squared. Force is equal to the resistive force is equal to kV squared. Same velocity. So you put kV squared here into V, then you get P equals kV cube. Now you have the relationship. Okay. What is that? Now, velocity of the boat is 5 meters per second. Power is 400 watt. Now the power of the boat is 400 watt. 400 watt equals K into V cube. V means velocity, that means 5 cube. Okay. Now they are asking the power if the velocity changes to 10. So the new power will be K into 10 cube. K into 10 cube. Clear? It's velocity, right? K V cube. K into 10 cube. Clear? Then you divide these two. P1 over 100. P1 over 100 equals, P1 over 400. This divided by this equals K into 10 cube over k into 5 cube. So you get the power P1 as k and k cancels out. You get 400 10 cube 10 cube over 5 cube 5 cube. Okay. Then the next one, P2 equals k. Next time the velocity of the boat is 30. So velocity becomes 30 and P equals kv cube, right? P equals kv cube. Then you divide this by this. P2 over 400. P2 over 400 equals k 30 cube over k 5 cube. K 5 cube. K and K cancels out. You get P2 equals 400 into 30 cube over 5 cube. 30 cube over 5 cube. Clear? Ah. So you need the interval? No, right? At what time do we end the session? Sorry? 12, right? Let's make it 12:15. 12:30 maybe. It took a bit of time to start the session, right? Due to, issues with SLT. I checked for the stocks like 2 weeks before at Singer for Starling, but wasn't there. Stocks were not available. Now I think they are available. But still, I think theoretically, fiber optic should be reliable than Starling, right? Because this is a wired network. So you're receiving everything wires. Even clouds can impact the Starlink Wi-Fi. You need direct path with a satellite. For fiber optic, you don't need that. So still we are using the most reliable form of internet and still we are having issues. Okay. Uh, so yeah, exercise 5. I have to teach Newton's law of restitution next. I'll teach that. For now, exercise 5. Question 10, 11. Question 10, 11. 12, 14 and 15. 12, 14 and 15. I won't give lot of time for this because these we did some questions. So you had the ability to try them at home. I gave time for exercise 7 because we didn't do any questions for practice. That's why I gave time for exercise 7 questions. I'll directly start discussing these questions after the interval. I won't give time to try them because you had the ability to try them because we did enough questions from these exercises. So you know how to do questions, okay? So the time is 10:12. I'll start around maybe 10:30. Okay, be here on time and start doing these questions. At least read questions quickly, okay? Okay. Exercise 5, question 10. Exercise 5, question 10. A 2 kilogram object a 2 kilogram object. It's a 2 kilogram object placed at 6 meters above the and released from rest. 6 meters placed 6 meters above and released from rest. If the rod is smooth, what is the velocity at B and C? At B, they are reaching to the bottom. At B, they are reaching to the bottom. At B, they are reaching to the bottom. This is 3. This is 3. And it reached C again. It's a 2 kilogram object placed at 6 meters above and released from rest. If the rod is smooth, what is the velocity at B? Velocity at B, VB. And next they are asking, okay, let's start from first part. What is the velocity at B and C? This is VC. So you always don't have to write equations like kinetic energy plus potential energy equals kinetic energy plus potential energy. What actually happens is, from here to here, what happens is we release a potential energy of mgh. We release a potential energy of mgh. Clear? We release a potential energy of mgh. Clear? It turns into kinetic energy half mv squared. It turns into kinetic energy half mv squared, right? Clear? The idea is, here you didn't have any kinetic energy. Now you goes 6 meters down. Now you goes 6 meters down. That means you release a potential energy of mg means 10, mg6. You release a potential energy of mg6. You release a potential energy of mg6. That is equal to half m v squared. Half m v squared. Half mv squared. M and m cancels out. You get v equals 2 into 10 into 6 square root. This is the velocity at B. Square root 120 meters per second. Then at C, then velocity at C, we see same story, but you don't go 6 meters down. From here to here, you go only 3 meters down, right? From here to here, you go only 3 meters down, right? I mean, you don't have to consider this, then this, then this. You can directly compare these two like that, okay? Because it's conservation of energy. It's conservation of energy. That means it is the same energy here, here, and here. Whatever the potential energy you release from here to here will be converted into kinetic energy at the bottom, right? Clear? And whatever the potential energy you release from this level to this level, which means when you are going down by 3 meters, whatever the potential energy you release from this level to this level, that means the potential energy you release when you go 3 meters down, okay, is converted into kinetic energy now, right? Here is converted into kinetic energy. From here to here, you go 3 meters down. Here, the potential energy belonged to that 3 meters. Now it will be converted into kinetic energy according to conservation of energy, right? That means M, again mgh, converts into half mv squared, converts into half mv squared. That means M G means 10. Height is from here to here. Height difference is 3 meters equals half m VC squared. M and m cancels out. VC is square root. VC is square root 60 meters per second. 60 meters per second. If the total work done, this is first one. If the total work done against the friction in coming from A to B is 40 joule, what is the velocity at B and C? Pay attention. Now this is the idea. When you go from A to B, when you go from A to B, when you go from A to B, you release a potential energy equal to mg6. Pay attention, pay attention. When you go from A to B, when you go from A to B, you release a potential energy equal to mg6. Initially, that whole mgh or mg6 was converted into kinetic energy half mv squared. Clear? Initially, that full potential energy was converted into kinetic energy half mv squared. But now, out of this mg6, out of this mg6, 40 joules are wasted. 40 joules is wasted against friction, right? Okay, you release mg6 potential energy. Initially, the whole potential energy was converted into kinetic energy. But now, out of this mg6, you lose 40 joules. You lose 40 joules against friction. Clear? After losing 40 joules against friction, only the remaining will be converted into kinetic energy. Clear? Only the remaining will be converted into kinetic energy. Okay. M is 2 kilogram. G means 10. Height is 60 minus 40 equals half. Again, mass is 2. Again, mass is 2. VB squared. 2 and 2 cancels out. VB squared equals VB squared equals 80. VB equals square root 80. VB equals square root 80. Now you go from A to C. Now you go from A to C. When you are going from A to C, you only go 3 meters down. That means mg3. Out of this mg3, initially, whole potential energy lost were converted into kinetic energy. But now, on the way from here to here, you lose 40 joules against friction on the way, right? You lose 40 joules against friction. So this energy minus 40 will be converted into kinetic energy, half m Vc squared. So you get m is 2 kilograms, G is 10. Here you have 3 minus 40 equals half. Again the mass is 2 kilograms. Again the mass is 2 kilograms into Vc squared. Into Vc squared. Clear? Okay. You solve this, you will get Vc. Third part I'm not going to do. Oh no, let's do third part too. Quickly write this. Quickly write this. Did you write the answer for that question? Did anyone write the answer for that question? Yes? Yes? Yep? No? If possible, if you get time, write the answer. Yes? I'm not asking about you to find the center of gravity or anything. The question was, when you move your fingers like this, anyways, it stops at the center of gravity. No matter how careless you do that, okay? You don't have to be careful, okay? Anyways, it stops at the center of gravity. Why? Either a mathematical explanation or a explanation as a paragraph, okay? Definitely involves friction, okay? A small help. Definitely it's how we regulate friction, how the friction is regulated. Next part, third one. If the loss from A to B is, if the loss from A to B is 80 joules, what is the velocity at B? Again, same story. Again, same story. I'll use the same thing. I'll use the same thing. From A to B, mg6, but now the loss is not 40, now it is 80, equals half mvb squared. Then you get m is 2 kilograms, g is 10, this is 6, minus 80 equals half, again mass is 2, vb squared. 2 and 2 cancels out, you get vb equals square root 40 meters per second when you solve this. Then again from A to C. From A to C, again same story, mg3, you release a potential energy of mg3, but on the way now not 40, you are losing 80, you are losing 80 equals half m vc squared. You get mass 2 kilograms, g 10, this is 3, minus 80 equals half, again mass 2 kilograms, vc squared. 2 and 2 will cancel out. You get vc squared equals, pay attention here everyone, you are getting minus 20 when you solve this, right? See, 3 into 2 into 10, 60, minus 80. You get minus 20 equals vc squared. This is not defined in physics, right? In maths, yes, you can define this stuff. In physics, this is not defined, right? How can a square be negative? There can't be any square numbers with negative values, right? Clear? Here you have vc squared minus 20. It's not possible, right? It's not possible, right? Why? When you multiply a minus number by minus number, you get plus. When you get plus number, multiply by plus number, you get plus. So when you multiply vc by vc, whether even when vc is positive or when vc is negative, vc squared will be always positive, right? Clear? Any square number is positive, right? In physics, practically. So this is not defined. What is the meaning of that? The friction loss on the way is too much. The object can't reach C. That means now they are telling that we are losing 80 joules due to friction. That means there's too much friction. There's too much friction. This will go like this. Then try to go up, but will stop on the way. Then will fall again. Clear? Friction loss is too much. You move down, you lose 80 joules due to friction. Now you try to go up again, but due to the friction loss, you don't have energy to reach here. So you are not actually reaching here. You are not actually reaching here. That's why you are getting a negative answer as the velocity at C. So just write, the object can't reach C. Object will not check. Object will not reach C. Question? If the object's velocity is 0, when it reach C, what is the work done against the friction? Let's find that. If the object's velocity is 0 when it reach C, what is the work done against the friction from A to C? Pay attention. Now what they are telling is, now what they are telling is, now what they are telling is, you start here, when you reach C, your velocity is just 0. When you reach C, your velocity is just 0. What is the meaning of that? From here to here, it is 3 meters, right? You lose a potential energy of mg3. The potential energy lost will be converted into work against friction and kinetic energy. But in this case, Vc is 0, that means this is 0. That means all the potential energy you lose from here to here is wasted against friction. Clear? All the energy you gain from here to here, all the potential energy you gain, that means you lose potential energy, it should turn into other types of energies. But now there's nothing left to be converted into kinetic energy because everything is wasted as work against friction. Clear? Work against friction. So the work against friction will be mg3. M means mass of the object, 2. G is 10 and you have 3. That means 60. Work is 60 joules against friction, 60 joules. Clear? That's why there's nothing left as kinetic energy. Let's see question 14 next. Let's see question 14 next. Let's go to question 14. Shall I explain that question? This one? Yep. Anyone still writing this? No. I'll roughly explain it. Later you can write a proper answer for that. And anyways, that question could be explained properly when we are done with forces a bit more. Okay. So the idea is this. I mean, assume that you are placing your fingers here and here. Okay. Assume that you're placing your fingers here and here. Okay. Then assume that the center of gravity is here. That means the whole weight is acting from this point. Whole weight is acting from this point. Okay. And this weight is balanced by the normal reaction here by this finger and normal reaction here by this finger, right? And now the center of gravity is too close to R2, right? Now the center of gravity is too close to R2. Clear? That means R2 force will be higher than R1, right? Most of the force will be felt by R2 because the weight is towards R2, right? Center of gravity is close to R2. Clear? Then mu R2 will be larger than mu R1. That means maximum possible friction here, I mean, when I move my fingers like this, okay, see, here it slips, here it slips, but here it's not. Why? Why? Because here there's a lot of friction. So here when R2 is large, mu R2 is large, that means the possible friction here is large. Possible friction here is large. Clear? So it will not slip here. It will stay there. But at the other end, it will slip. At the other end, it will slip because the friction there is lower than this one. Clear? So this finger will move in this direction. This finger will move in this direction. Okay. Now you bring this finger here. Now what happens? Now this finger is close to center of gravity than this one. Clear? Now this finger is close to center of gravity than this one. Okay? Because it comes closer due to less friction. So as a result, R1 becomes larger than R2 here. R1 becomes larger than R2. Clear? So mu R1 is larger than mu R2. That means friction here is now larger than friction here. So here now it will not slip anymore. Okay? The other hand will slip. See? Initially this hand was slipping, other one was stationary. But when you bring it closer to center of gravity, this hand will be slipping, other one will stay stationary. Clear? Other one will stay stationary. So this one now, this one will start slipping, this one will stop. It will move in this direction. After a certain time, again this one will move. After a certain time, again this one will move until both fingers reach the center of gravity. Okay? The friction is automatically regulated by the distance you have to the center of gravity. Clear? Friction is automatically regulated by the distance you have to the center of gravity. Clear? That is the idea. Okay? So you have to be able to write this stuff, then write it as a paragraph. That's the idea of getting marks for physics paper. Okay? I mean, you may have an intuition about what is happening, but expressing it properly like this and writing it as a paragraph, converting it into a proper answer, it is also a different thing. Okay? It's again, it's a different skill set. It's not physics. It's a different skill set. Explaining this. Okay? Explaining and knowing physics are two things. Some people may figure out, understand physics very well. They may not be able to express it in words. At the end of the day, to get marks in A levels, you must have that ability. Okay? Now, I mean, and focus a lot on careless mistakes. Okay? I can show you the message. It's on my phone. Like, one of my students have 49 in MCQs. Okay, 49 MCQs out of 15. Out of 50. I have asked them not to check. Okay, but they anyways check. So okay, there are 49 MCQs. Okay, there's only one wrong answer. Wrong answer is he has forgotten to. I mean, it's just to like an FT graph. FT graph, and there's a triangle like this, as I saw that. He has forgotten to divide it by 2 when taking the area of a triangle. Okay, when taking the area of a triangle, he has forgotten to divide it by 2. That's why 49 MCQs, not 50. But this is okay. Why? Only one careless mistake. So 49 is manageable, right? Okay. So, but the thing is, I received another message from another student. I mean, he was in section top 5 Ananda College continuously. He has done like 4 5 careless mistakes, like similar mistakes, like 4 5 careless mistakes. It's too much. This is okay. I mean, no matter how good you are, you will do 1 or 2 things like that in A levels, okay? Definitely, okay? Most easiest stuff, you get wrong answers in A levels, okay? Not the most difficult ones. Why? In the most difficult ones, we give our maximum attention. When the question is easy, we forget to give our attention, right? We think about the next question or previous question when we are doing an easy question. When you are calculating the area of a triangle, what happens is your attention is not there because it's too easy to find the area of a triangle. Your attention is on the next question or on the previous question. Okay. So one of the main skills you have to learn is to how to hold your attention on what you are doing. Okay. It is a very crucial skill. So this is okay. 49 MCQs manageable. Anyways, for sure getting an A, almost an A about 95. Okay. No big issue. Okay. No big issue. But the problem is that student, another one, he was section top 5 continuously. 4 or 5 careless mistakes like this, similar ones. Okay. All the difficult questions have managed properly. 4 or 5 careless mistakes like this means your district rank is going down by around 100. Okay. You make 4 or 5 careless mistakes like this, your district rank would go down like by like 100 at least. Island rank would go by around 300, 350, 400. Okay. So 4 or 5 careless mistakes is too much in A levels. Okay. But anyways, he will get an A and he will get selected to University of Morocco because anyways, you can write the essay paper pretty well. I mean, he's anyways good at physics. But 4 or 5 careless mistakes is too much. Okay. So you have to focus on that too, about your careless mistakes. Okay. This is okay. Only one careless mistake. It is a pretty stupid careless mistake. It's a different story. Okay. And the main advice I give is don't check your MCQs before you are done with A levels because you get an additional pressure through that. Okay. But I mean, they never get that advice serious. Only when you check your MCQs pretty confidently and when you figure out, okay, you don't have that many MCQs, then only the real problem starts. Okay. For this 49 guy, it's not issue. You are anyways relaxed now, right? You have 49. It's a good thing. But when you get when you are expecting 49, if you get 44, then it's a problem. Then the real problem starts. Okay. Question 14. Question 14. One more question. I think, did anyone pay attention? Did anyone get the answer for this? I think I gave this question in this class, right? Or Sunday one, I can't remember. This one. There's a setup like this. It was on Sunday class. So you also try this, okay? There's a bunch of questions given like this. I'll explain everything. I'll put online session and explain all the questions. Okay? So the question is, pay attention everyone. A random question, not related to work, power, energy. I just need you to try some nice questions if you're done with the exercises. That's all. That's why. Okay? Because the part is, we learn theory. Through the questions in the tute, we learn how to apply theory. Through these kind of like small questions, we learn how to think a bit out of our scope. Okay? How to think a bit out of our scope. That is the idea. So here the question is, these two are similar. Mass is m, radius is r. Mass is m, radius is r. All three are similar and touching each other like this. Pay attention. If there is no friction on the floor, if there is no friction on the floor, pay attention. If there is no friction on the floor, what will happen? Three similar spheres, radius r, no friction. What will happen if you release it like this? These two will move like this and this will fall down, right? These two are touching each other, okay? I need you to find the minimum force that you should give from this side to keep the setup like this without slipping. The gap between them should not increase. Now what happens is when you push this, these this setup will accelerate very fast in that direction so that it will not fall, right? See, here also if you move your hand fast, this will not stop, right? Clear? This will not fall. Like that, if you don't have a force, these two will go like this and it will fall. Clear? But if you provide enough force in this direction, I'm asking the minimum required force, then the system will accelerate and the system will stay as it is. The distance between them will not increase. But I need you to find the minimum force. Okay? If you provide 10,000 newtons here, system will accelerate really fast, system will not collapse. System will stay like that. But I need you to find the minimum required force to keep the system like this. Okay? An additional question, nothing related to work power energy. Let's go to question 14. If you have additional time while trying these questions, then try them. An object of mass 1.6 kilograms is placed on a smooth surface. Exercise 5, question 14. It is attached to the light horizontal helical spring. Its spring constant K is 1 into 10 to the power 3. Spring constant K is 1 into 10 to the power 3. The spring compresses 2 centimeters and released. You compress the spring by 2 centimeters. You compress the spring by 2 centimeters and release. If the surface is smooth, what is the velocity with which it passes the equilibrium position? So now when you go from here to equilibrium position, what happens is, if I write things properly, if this is position A and if this is position B, kinetic energy plus potential energy at A is equal to kinetic energy plus potential energy at B. Kinetic energy plus potential energy at A is equal to kinetic energy plus potential energy at B. Clear? Sorry? Here. I had to check. We'll do. Show me the calculation. Kinetic energy plus potential energy at A is equal to kinetic energy plus potential energy at B. So what happens is, here the kinetic energy is 0, it is stationary. Here it is stationary plus potential energy is elastic potential energy, half K x squared. When the spring reached to the natural length again, kinetic energy turns into half mv squared, but elastic potential energy is 0, right? Why? At the natural length, there's no elastic potential energy. Here there is no kinetic energy, here there is no elastic potential energy. Elastic potential energy converts into kinetic energy. Clear? So you get half, what is K? Spring constant. Spring constant is 1 into 10 to the power 3. 1 into 10 to the power 3. You compress it by 2 centimeters. You can compress it by 2 centimeters. This is half K x squared equals half m. What is the mass of the object? Mass of the object is 1.6. 1.6 v squared. You solve it, you get v. Okay? You solve this, you get v. Clear? Show me the answer. You are providing the force only from one side, okay? Okay, pay attention. The question is not that simple. You are not providing the force from both sides. You are only providing the force from one side. Okay? You are providing the force only by one side. Then purely by the acceleration you hold the system. Clear? Purely by the very fast acceleration you hold the system. If you are providing the force from both sides, then it's simple. You are only providing the force from one side, and purely by the fast movement of the system you hold the system. Okay? You won't allow the system to collapse. Okay? Okay? It's not, you are providing F here and F here. It's not like that. You only provide F from this side. Then the question is a bit complex than usual. Is this clear? Is this clear? Elastic potential energy half kx squared equals to the kinetic energy you get here. If the frictional force acting on the object is 0.5 newtons, what is the velocity with which the object passes the equilibrium position? Now what happens? Now on the way there's a friction. On the way there's a friction. What is the friction value? 0.5. So now the idea is, we know that the work against the friction is Fx. We know that the work done against the friction is Fx, right? Fx. F means value of the friction, 0.5 newtons. F means value of the friction, 0.5 newtons. X is the distance you travel, 2 centimeters. X is the distance you travel, 2 centimeters. Clear? Work equals Fx. F is 0.5, distance 2 centimeters. Okay? So you get half into 2 into 10 to the power minus 2. So you get 10 to the power minus 2. 10 to the power minus 2 joules. 10 to the power minus 2 joules. Clear? Now what happens is, now it's not just half kx squared. You release half kx squared of energy from the spring. You release half kx squared energy from the spring, but you lose 10 into 10 to the power minus, 10 to the power minus 2 due to friction. Clear? You release half kx squared from the spring, but you lose this much due to friction. Clear? Only the remaining part will convert into kinetic energy, half mv squared. Half 1.6 v squared. Only the remaining part will convert into kinetic energy. Clear? Now you get the new velocity. Okay? Okay? So today's session is done at 12, right? It will be a maximum 12:15, but like just inform, okay, if you thought the session is until 2, okay, just inform. If you need a mobile phone or anything, just ask from our coordinators. Or else if you need, you can stay here until 2, okay? No big issue. You can stay here and work, no big deal. Just stay in the hall and work. I mean, anyways, the hall is usually open, okay? I'm always here, not on Wednesdays and Saturdays. Except for Wednesdays and Saturdays, and sometimes on Fridays, not on Fridays. I mean, the idea is, if you need to work here, if you need to come here and ask questions, just let us know, okay? Just let us know, then we can arrange. It's quite difficult to arrange stuff on Saturdays and Wednesdays, okay? Because most of my staff and invigilators are at Ratnapura those days, Wednesdays and Saturdays. But on other days, yes, it's possible, okay? Any day, just let us know. We can arrange some invigilators if you need to ask questions. I mean, with this temperature, the AC looks like a fan, right? What is the point of having a AC at this temperature? Okay, think you're done with this. Uh, I need you to, I need to teach two theory parts. I'll do that before moving to other questions. One is out of syllabus, but I need to teach that. Pay attention. One is, and one term you should know, conservative force fields. I didn't teach that term, right? Conservative force fields, just a term that you should know. There are types of fields. What are the fields? There are gravitational fields, electrostatic fields, magnetic fields. These are fields. These are fields. Uh, Conservative force fields are the fields that the work does not depend on the path traveled. One such example, and the only example that you know at the moment, is gravitational field. Why? In gravitational fields, if you have a mass here, and if you take it here by a height of h, what is the potential energy difference? What is the energy difference? mgh. That means the work you should do is mgh, right? Work you should do is mgh to take it from here to here, right? Because the energy difference, potential energy difference is mgh. So the work you should do is mgh, right? Work you should do is mgh, clear? But whatever the path you travel, it's same, right? Whatever the path you travel, the energy difference is, if the height is h, energy difference is mgh, right? That means it is independent from how you go from here to here. It's independent from how you go from here to here, clear? Independent from the path. These type of stuff we call conservative force fields. I mean, take friction for an example. It's not a system like that. Why? If you have a friction, if you go in a lengthier path, you will feel a lot of friction on the way. So you need more energy, right? So if you go in the shortest path, you will lose less amount of energy due to friction, right? Because the friction is there throughout the path, throughout the road. So if you choose this path, you have to go a small distance under friction. So you will save more energy. But when it comes to gravitational fields, no matter what is the path you choose, energy difference is mgh. So the work done is mgh. So conservative force fields, just a term, okay, you should know. Conservative force fields are fields that the work done is independent from the path you travels. Other such fields are usually electrostatic fields and magnetic fields. Okay, and you have three separate lessons to learn these three topics. Okay, you have a lesson called gravitational fields. You have a lesson called static electric fields. You have a lesson called magnetic fields. Okay. Okay, it's one term. The other thing I need to teach you is, pay attention. The other thing I need to teach you is this. Now, can you remember? This is M1, this is M2. This one goes like this V1, this one goes like this V2. They collide. After the collision, this one goes with a velocity like V3. This one goes with a velocity like V4. Can you remember the two equations we wrote for this? This works for elastic collisions only, okay? One is conservation of momentum. For conservation of momentum, you don't need an elastic collision. Conservation of momentum works for any scenario, okay? So what is conservation of momentum? M1 V1 plus M2 V2, momentum before the collision, equals M1 V3 equals M1 V3 plus M2 V4. Clear? Clear? Then if this is an elastic collision, that means there's no energy loss, right? Can you remember? If this is an elastic collision, there is no energy loss, right? Clear? That means the kinetic energy before the collision is equal to the kinetic energy after the collision. That means half m1 v1 squared plus half m2 v2 squared equals half m1 v3 squared plus half m2 v4 squared. Kinetic energy before the collision, half mv squared equals kinetic energy after the collision, half mv squared plus half mv squared. Clear? But solving these two is bit of a trouble sometimes because there are square terms, right? There are square terms, okay? By solving this, you can find v3 and v4, right? There's another law called Newton's law of restitution. Newton's pratyagati niyamaya. Okay, Newton's law of restitution. Uh, Actually, he found these equations when he was a kid. Okay, uh, I mean, the Newton came up with optical laws, lot of stuff before he was 20, I think. Okay, many laws. So, but he wasn't able to prove a lot of stuff. He just imagined. Okay, so anyways, pay attention. Now, this is the idea. This is the idea. Pay attention. The next part that I'm going to teach is out of syllabus. So if you don't understand it, forget it. Okay. These two is sufficient to go for answers. You solve this, you get a quadratic equation, you get the answer. No big issue. So you solve this, you get the answer. Next thing that I'm teaching is out of syllabus for physics. So if you don't understand that, forget it. So the idea is this. Newton said, in an elastic collision, relative velocity of them moving towards each other is equal to the relative velocity of them moving away from each other after the collision. What is the meaning of that? It's like this. Now see, now before the collision they move towards each other, right? Before the collision they move towards each other, right? What is the relative velocity that they move towards each other? V4, sorry, V1 minus V2. V1 minus V2, right? Why? This one is moving towards, this one is moving away. So the relative velocity between them is V1 minus V2. V1 minus V2. This is the relative velocity of them moving towards each other before the collision. Should be equal to relative velocity between them moving away from each other after the collision. Now what is the relative velocity between them after the collision? Due to V4, you go away. Due to V3, you get closer. I need the relative velocity of moving away from each other. That means V4 minus V3. V4 minus V3. So you can easily solve this equation and get very fast answers, okay? You don't have to go for V squared terms. You write this, you write that, you solve these two. You get very quick answers, right? I'll do an example. But the problem is it is out of syllabus. So what you do is in the MCQ paper, no one cares. In the essay paper, you write this, you write this. I explained that there are no marks assigned for calculation steps. So you write this in a rough paper, you solve these two, you put the answer. Clear? Okay. You write this, then you write this. You are not going to solve these two. You write this on a rough paper. You solve this and this. You solve this and this. Then you put the answer here. Okay. Same answer you are going to get for elastic collisions. Clear? So the Newton's law of restitution means the relative velocity of them moving towards each other is equal to the relative velocity of them moving away from each other. Clear? Got the idea? Okay. So here definitely, since this is before the collision, Okay, definitely V1 should be larger than V2, right? For them to collide, definitely V1 should be larger than V2, right? Before the collision, otherwise they will not collide, right? So the relative velocity here is V1 minus V2. Now this is after the collision. After the collision, definitely V4 should be larger than V3, right? Otherwise they will collide again. It's not possible, right? After one collision. So definitely V4 is larger than V3 after the collision, right? Then only they will move away from each other. So the relative velocity between them is V4 minus V3. Clear? You solve this and you solve this, you get the answer. Clear? Okay. Um, for an example, last week using these two we solved exercise 6 question 1, right? Let's do the same thing using these two. Last week we did exercise 6 question 1 part 1. Last week we did exercise 6 question 1 part 1. Okay. Last week we did exercise 6 question 1 part 1, which is m into 5, m into 5, and pay attention, m into 4. We solved this last week, right? I think we did this last week, right? Yes, right? Okay. So today, let's use the other equations. Now, what are the steps? Velocities after the collision, V1, V2. So the idea is first conservation of momentum. That means m into 5 plus m into 4, m into 5 plus m into 4 equals m into V1 plus m into V2. So when you solve this, you get m and m cancels out. You have 5 plus 4, which means 9 equals V1 plus V2. Then you write kinetic energy, conservation of energy. Half m V1 squared means 5 squared plus half m, this is 4 squared, equals after the collision half m V1 squared, after the collision half m V1 squared plus half m V2 squared. You don't worry about this one. Okay. You apply Newton's law of restitution. What is that? What is the velocity of them getting closer to each other? Relative velocity? Initial relative velocity? 5 minus 4. 5 minus 4. This is the relative velocity before the collision, right? 5 minus 4. Clear? What is the relative velocity after the collision? Definitely, since it's after the collision, V2 should be higher, right? Because it's going away. It's going away, right? After the collision. So relative velocity after the collision is V2 minus V1. Clear? V2 minus V1. So you have now V2 minus V1 equals 1. And you have V1 plus V2. You have V1 plus V2 equals 9. You solve these two, which is really easy. You add these two, V1 and minus V1 cancels out. You get 2V2. 2V2 equals 10. So V2 is 5. V2 is 5. And V1 becomes 9 minus 5, which means 4. This is on your rough paper. This is on your rough paper. You write your answer here. V1 is 4. V2 is 5. V2 is 5. Clear? Clear? Can you remember we got the same answers last week? Yes? See? Newton's law of restitution makes it really easy to handle, okay? Makes it really easy to handle things. In maths, you will learn a better law of restitution with E and some, in maths syllabus, you will learn Newton's law of restitution. There are some additional terms accounting for the energy loss too. Here we are applying Newton's law of restitution only for elastic collisions. But in math syllabus, you will learn a law that you can apply when there are energy losses too. Okay. but we don't have to go to that extent. They will never ask. Okay, they will never ask. But be careful, don't apply that if the collision is not elastic. What are elastic collision? Collisions that kinetic energy is conserved. No energy lost in the collision. Clear? Okay. Quickly try second one. Quickly try second one. Exercise 6, part 1, part 2. Exercise 6, question 1, part 2. I mean, I need you to I need you to write this equation too. Then write that, then solve and get the answer. Okay. Uh, Part 2, m, velocity 3, then m, velocity 2. Now there's a small problem. Pay attention. There's a small problem. They are moving towards each other. What may be the relative velocities? I mean, what may be the velocities after the collision? What will be the directions of velocities after the collision? You don't have to worry about that, okay? You don't have to worry about the velocities after the direction of velocities after the collision. Why? You just, if you like, you just mark them like v1 and v2. Why? If this is not the actual direction for v1, you will get an minus answer. Okay? Don't worry when marking the direction of the velocities after the collision. Okay? Why? You just mark them any way you like it. If this is not the proper direction, you will get a minus answer. Clear? So the equation will provide you the proper magnitude and direction both. If this is not the proper direction, you will get a negative answer anyways. Okay? So you don't have to worry about that. Okay? So I'll just mark them like this in the same direction. So conservation of momentum in this direction, conservation of momentum, m into 3, here minus, why? This mass is in opposite, it's coming in opposite direction. So minus m into 2, m into 3 minus m into 2 equals, after the collision, m into v1 plus m into v2. Then m cancels out. 3 minus 2 is 1 equals v1 plus v2. Clear? You should ideally write this one too. Kinetic energy before the collision, half m 3 squared plus half m 2 squared equals half m v1 squared plus half m v2 squared. Kinetic energy before the collision, half m 3 squared, half m 2 squared. Kinetic energy after the collision, half m v1 squared, half m v2 squared. Then you write Newton's law of restitution. What is that? Relative velocity before the collision. Now what is the relative velocity before the collision? It is 3 plus 2, right? They are moving towards each other now. They are moving towards each other, which means relative velocity is the addition, right? 3 plus 2, right? They are moving towards each other. Clear? Relative velocity before the collision is 3 plus 2. Relative velocity after the collision, v2 minus v1. v2 minus v1. Clear? v2 minus v1. Clear? Okay? Then you get v2 minus v1 as 5. You take this one as 1, this one as 2, you add these two. When you add 1 and 2, you get 1 plus 5, 6. 1 plus 5, 6. Here, v1 minus v1 cancel out, v2 plus v2, 2v2. v2 plus v2, 2v2. Then v2 is 3. v2 is 3 meters per second. If v2 is 3, what is v1? From this, v1 is 1 minus v2, 1 minus v2, that means 1 minus 3. 1 minus 3 means minus 2. The meaning is v1 is minus 2. That means actually it is 2 in the opposite direction. Clear? It is actually 2 in the opposite direction. v2 is 3. v2 is 3. That means it is 3 in this direction. Clear? It is 3 in this direction. Got the idea? Conservation of momentum, energy conservation, Newton's law of restitution. Clear? They are moving towards each other, so the relative velocity before the collision 3 plus 2. After the collision v2 minus v1. Clear? Because v2 is faster than v1. Clear? v2 is minus v1. Clear? v2 minus v1. So when you like pay attention, so when you are like writing this Newton's law of restitution, you can think it like this, okay? If this is v1, I mean just an additional point, like pay attention, think this is the velocities before the collision, this is the velocities after the collision, this is the velocities after the collision. When you are choosing positive and negative, you can think it like this. It is relative velocity before the collision. Pay attention, pay attention. It is relative velocity towards each other. So towards each other means this direction and this direction, right? So when you are writing it, whatever in this direction will be positive. So this is plus V1, see? Plus V1 and plus V2. And moving away means this direction and this direction, right? So this is in the proper direction, see? Moving away. So you write V4. This is moving away, but this is in opposite direction, against moving away. So it should be written as minus V3. You can use that to write things properly, okay? Again, for an example, assume before the collision V1, V2, before the collision V1, V2, before the collision V1, V2, okay? Let's think after the collision V3, V4, V3, V4, like this. How are you going to write Newton's law of restitution? Pay attention. Before the collision, it is relative velocity of moving towards. So you draw lines towards, and after the collision, it's relative velocity moving away. Now see, this is towards V1. See, these two are in the same direction. This is against moving towards. See, if you have to move towards, you should go in this direction, but it is against that. So you write it as minus. Here moving away, this is supporting to moving away. See, this is supporting to moving away. V3. This is also supporting to moving away. See, V4. Clear? So if you can't figure out this relative velocity towards and relative velocity away stuff, what you do is, if these are the velocities before the collision, u1, u2, if these are the velocities after the collision, v1, v2, okay, how do you choose positive and negative? Initially it is towards, so you draw two lines towards. After that it's relative velocity away, so you draw two lines away. If you can't figure out this proper positive negative thing, you just draw two lines towards, okay? Then after the collision, you draw two lines away. If these two are in sync, you write positive, otherwise negative. So this and this is opposite, see? This one and this one is opposite. So it should be written as minus u1. This one and this one is in the same direction, so you write it as plus u2. Here, this one and this one is opposite, see? These two are opposite, clear? These two are opposite, so you write it as minus v1. This one and this one is in the same direction, so you write it as plus v2, see? So if you can't figure out this relative velocity of moving towards, relative velocity of moving away, you just use this, okay? Anyways, you are getting the correct answer, okay? Clear? Draw two lines towards, draw two lines away, then see who supports towards, who supports away. Okay, clear? There's one answer, two, three answers about the sphere question. One answer looks correct. We'll see. If I don't find time for that today, I'll do it in the main class. Anyways, there's a bunch of questions that I should do. I'll try to do them as a recording, or let's take one day from the class and do all those questions. And the reason for not doing the session until 2 today is, I mean, you anyways have a 10-minute attention span, so there's no point of teaching for 6 hours. Okay. There's a sheet mentioning that it's only 25 minutes more to the end of the class. Will I finish the class in 25 minutes? Yes. There's a sheet mentioning asking whether I'll finish the class within 25 minutes. Yes. Okay. Should have given the cheat on time. Okay. Let's go to question again, exercise 5. Uh, let's try question 15. Let's try question 15. There's a small correction there. We are asking the velocity of the chain as it leaves the table, not the acceleration. We are asking the velocity of the chain when it, we are asking the velocity of the chain when it leaves the table. And the other thing is you have to pay attention, pay attention. Other thing is you have to like use the center of gravity here, okay? So this center of gravity issue occurs ideally, we do work power energy after center of gravity. That's why. That's the issue here, okay? Sometimes you have to do questions with center of gravity. The problem is ideally the syllabus is planned to do center of gravity, like before work power energy. But you may have to use the center of gravity concept a bit here. Exercise 5, question 15. Exercise 5, question 15. Question 15. And just let me know if there are any other questions related to theory. Tomorrow also you have a similar session, but you don't have to join if you join this session. And I mean, we had to delay past paper, term test paper discussions for 2 weeks because I had to do rotational motion and everything. Okay, but from this week, let's resume term test paper discussions again. So we have a class at 12:30. Ask him to wait. 5 minutes, 5 minutes. I mean, none of the class do anything useful within the first 10 seconds, right? Within the first 10 minutes, right? So like going to the class 10 minutes late won't do any harm. Okay. Question 15. There's a chain like this. Now it starts slipping like this. Now it starts slipping like this. Okay. Now it starts slipping like this. Then it completely gets out of the table at this point. They are asking if this starts at 0 like this. That means at here, you give a small push. Then it starts with 0 velocity. Then it keeps going down like this. Okay. It keeps falling off the table like this. What will be the velocity of the chain when it completely gets out of the table? Clear? Clear? It starts slipping like this. Then it keeps falling off the table. Then it entirely falls off the table. When it entirely comes off the table, what will be the velocity? Clear? What will be the velocity? Okay, clear? So again a simple conservation of energy. Okay, why? Here velocity is 0. Again A, B. Kinetic energy plus potential. I mean, I don't have to write that also. Like when you fall down, you lose some potential energy, right? When you fall down, you lose some potential energy, right? That potential energy is converted into kinetic energy here, right? That potential energy converts into kinetic energy, right? Now the problem is, pay attention everyone, pay attention. Now the problem is, if you consider this particle, it went from this level to this level. If you consider this particle of the chain, it went from this level to this level. If you consider this particle of the chain, it went from this level to this level. If you consider this particle of the chain, it went from this level to this level. Each particle goes down by different lengths, right? Each particle of the chain goes down by different lengths, right? This particle was at that height, this particle is still at that height. This particle was here, now it is here. This particle was here at this level, but now it is here. See? The distance traveled down by different particles is different from each other. Okay? So you can't analyze the system like that. Okay? So what is the solution? You consider one point to represent the whole chain. You consider one point to represent the whole chain. What is that? The center of gravity. You consider one point to represent the whole chain, which is the center of gravity. So in this Thursday and Sunday, you will learn more about center of gravity, okay? But anyways, Center of gravity lies in the middle of a uniform object. So it is here now, at the middle. Clear? Again, the center of gravity here is here, at the middle. What is the length of the chain? 4 meters. So then this is 2 meters. This is 2 meters. Clear? That means this is 2 meters. This is 2 meters. And this is 2 meters. Clear? Center of gravity is at the middle. So actually, center of gravity went down by, it was initially at this level, it went down by 2 meters, right? Center of gravity went down by 2 meters. That potential energy you lose when you go down converts into the kinetic energy of the chain. Converts into the kinetic energy of the chain. Clear? That means G means 10. The center of gravity goes down by 2 meters. Center of gravity goes down by 2 meters. Clear? Equals half, again m, velocity is v squared, half m v squared. Clear? Clear? M cancels out. V squared equals, you take 2 here, 40. V becomes square root 40 meters per second. Square root 40 meters per second. Clear? Got the idea? So just finish all the exercises in the tute. What I would do is I will finish coplanar forces in the main class. After that, if there are any remaining questions, I'll do that in the main class. Then I'll do the past paper discussion of both coplanar forces and work power energy together in the main class. Okay. I'll do both together in the main class. So just finish the whole tute, and if you have any issues, ask from us at the class. And if you need to get the tutes or to join the groups or anything like that, contact this number, not 70-154-6825. Okay, clear? Yeah, so let's stop it now for today. And thank you. Contact this number if you need to know anything.